Oh, all right, the slides are working. Awesome. So, I'm here to talk about Zed today. How many people out here, just a show of hands, use VS Code? All right. I don't know about you, but I hate almost everything Microsoft. I'm not a big VS Code fan. So about a year ago, I found Zed, and Zed is lightning fast. And one of the things I really like about it is I can use Zed for everything. Currently, I'm coding in TypeScript, I'm coding in Python, I'm even coding in Java, and I can use the same editor for all of that. Kind of like you can do that with VS Code, but as you guys know, the more stuff you pile on VS Code, the slower and slower and slower it gets. I don't seem to have that problem with Zed. So I thought today I would try to convince everybody here to switch over to Zed, and it's as easy as signing into GitHub. So I took this directly from their website, and I do have some links that I can share out at the end of this. But Zed is a next generation code editor. It's actually built on Rust, and it's built on a game engine. So if you can imagine switching from file to file and even just opening up the system, you know, it's kind of hard in a small repo to see the speed differences, but I've opened up some really large repos, and it is quite a bit faster than VS Code. I mean, give it a try. What could it hurt, right? And was specifically designed not only to work with collaboration, like you can work with anybody who has downloaded Zed and who has logged into GitHub. It's that easy. And it was built purposely around using AI, which, as everybody knows, is the wave of the future, whether you want it to or not, I guess. And so I came up with some pros and cons of why you should be using Zed. Big pro for me is it is super fast, and it is built to work with AI. I'm going to do some demonstrations here in a little bit. I think you'll like that. And it is built specifically for collaboration. You know, I know VS Code has LiveShare, and I've used LiveShare, and I've used Zed's LiveShare thing, and I like it better, but I am a little biased on that aspect. And it does have a first-class VM. If you're used to using NeoVim or something like that, you will find this very handy to use. And it does have Git support, you know, just like everything else. And they do weekly releases. And to be honest with you, they do almost daily releases or every other day, but they do big releases every Wednesday. So every Wednesday you get brand new functionality and everything. But there are still some cons. You know, nothing's perfect. One of the big ones for me is it is still in beta. It is an open source model. You can actually contribute to it. I've downloaded the Rust application, and I'm actually going to show you a little bit of some of the Zed code here in a minute. But it is still in beta, so it's not perfect. Their plugin ecosystem is not nearly what VS Code's is. And there's still just a small number of users. Up until, I think it was last week, they only had support for Apple and Linux, but they now support Windows. So if you have a Windows machine, you can download Zed and play with your heart's content. And like I said, I will see about sharing these out to the Discord after the meeting, but the website's pretty easy, zed.dev. You can find everything from there, other than their Reddit page, but everything else has links from their website, and their website is pretty slick, and they have way more examples that I'm going to show you tonight on their website. So if you want to take a look at it, I suggest you give it a shot. So now, let's do a quick demo. When I tried this, let me see how it looks. Let me see if I can make it look better. Does that look a little better? A little bit? I loaded up some Java or some Python code because I figured you guys would like Python. But this is Zed. And what I was saying about on the GitHub stuff is, I didn't sign in, there you go. So you sign into GitHub, you can see, the part up here where it says channel Zed, these are all the channels that Zed itself is working on. You could actually, if you had a question about Vim or whatever, you could actually hop into their Vim channel and you could talk to them about it. You can tell this one actually has somebody in the channel. Or what I have is I have a couple friends who are offline, and if they were online, I could literally click on them, invite them to my thing. They would have they could see my screen, they could edit my screen, they could do everything just like you could in Live Share, only I think it works a little bit better. It was a little bit more smoother, it was a little bit more easy to work with. The other thing too is it was completely designed around AI. You can, like I said, it is an open source editor, but they do make their money. They have their own AI. You can buy tokens from them, and you can buy subscriptions from them, and you can actually run their AI. They have Claude AI. They got all the ones just like you want. But you can also bring your own keys. So if you have an Anthropic key, or I have, let's see, where is my Copilot? So I'm logged into Copilot here, and so I brought my Copilot information here, so I can actually run, and I can even come down here and I can bring up the Zed stuff, and it will tell you that I've only used 4% of my Copilot this year, and you can run anything you want. You can be in here like, hey, how do I make this game look better? It's that easy. Now, the one thing I like and I dislike about Zed's AI configuration is it does not use the Copilot instruction MD file that's in your .config file. Instead, they have what they call rules. But what you can do is literally take that file, copy and paste it into here, make absolutely no changes to it, and it works just fine. And I like that. You can also have multiple rules, and you could even, just like in Copilot, you could have a .z folder in here, and you could set settings and everything just for this project, much like you can with the .vs code directory in your project, and that would have stuff only for that project. And you could still have, and they do have, up until recently, all of their settings were done in a JSON file, but they have recently added a nice little GUI for their settings stuff. So it's really coming along, and like I said, every Wednesday they do major releases. If you go to their website, let me see where are we at, zed.dev, and like I said, just on here they have multiple examples of stuff you can look at, but the big one I always try to hit is view all releases. So you can tell, this will tell you everything they have for all their releases. I wish I could, there we go, a little bit better. But they'll tell you what's in each release. So here are some minor releases. They fix some bugs after their major release. And then they'll get down here to a major release. Well, this looks like it's one of them. And it just goes on and on and on, the stuff that was in this release. So that is kind of what I have for you. Does anybody have any questions about why you should be switching to Zed? Absolutely. Go ahead.
Do you know off the top of your head of any notable plugins that are missing currently from the ecosystem?
So they have opened up the plugins, like you could create any theme you want. So there are like a billion themes. You can go, if there's a theme for VS Code that you like, you can get that same theme in Zed. But, and they've also opened up plugins if you wanted to build a plugin to add support for a language. Like they have some languages that are just internally. So like you have Python, it's built in Rust. So you have Rust. It's JavaScript, TypeScript is built in. Python is all built into the system itself. But they have other ones. Java, they have a plugin for. They do have a debugger. I've used it a few times on TypeScript code, but I've not used it on Python or Java. I think, you know, the bad part is, or not the bad part, but if you're a pure Java developer, you're probably going to, you know, I think IntelliJ is still probably the main dog. I mean, it's just good at what it does. But the one thing I really like is that I can work for a little bit in a TypeScript project, and then in the afternoon I can switch to a Python one, and then I can switch to a Java project later in the afternoon or whatever, and I don't have to change any of my settings. And I know in VS Code, you can set up your profiles. So you can have a Java profile, and you can have a TypeScript profile, and you can do that. But when you open up a project, you may have to switch which profile you have active. And I don't have to do that in Zed. It just, the whole thing is the whole thing. But yeah, yes?
So if I'm pair programming with someone, can they run commands in my terminal?
I believe they can. It's been a while since I've used it. On the project that I'm currently working on, I'm the only one who uses Zed, so as much as I'm trying, yeah. But we'll see. I'm slowly going to wear some of them down, I hope. But I believe you can. Oh, my Zed thing just finished. Ugh. So just like with anything else, I have it on agent mode. So Zed made a bunch of, or the AI made a bunch of changes, gave me a summary of the changes, and then made the changes in the code. Yes.
How often do you have to stop what you're doing and restart the editor for it to apply an update?
Typically they do the updates in the morning, so before I get into work. So usually I don't. Except for the Wednesday updates, the big major ones, a lot of times those seem to happen around noon. So yeah, but you don't, what it does is right here at the bottom, it'll say, hey, there's a new update for Zed. And you either click it and then the thing literally vanishes and comes back up and you're back to working, or you don't and you can just get it the next time you turn it on. And then the other nice thing is that then in the other corner, when you do finally update it, it says, hey, do you want to read the README notes for the release right there? And it just opens it up as a tab in your editor. And you can read through what changes happened. So it's, even when it does, it's literally just, you know, like VS Code, when they change a plugin, you just click a button and it just, that's kind of, it's a little bit more, I mean, the whole app will go down and then back up, but it really is. I mean, here, let me show you how fast. Now, like I said, this is a small project, but that's how fast it came out. And you can even, oh, I did want to show you guys this, and then I probably got to hand off to somebody else. But right here, I have all the Z code, and I can actually, like I said, it's in Rust. I can actually, I've already pulled down their latest change, and I've built it, but I could actually run the very latest Z code right from here, and I could test things out and all that. So if you wanted to actually help with the development of Z, you can actually do that and test it locally and put a pull request out there and be a hero. I'm not a Rust expert, so I have not. But you have another question, Joey?
You might have already covered this, but when you go to work in a new language and you want language server support, is that usually just a plugin like VS Code and you can configure it? Or is it
Yes.
configure the LSP?
Yeah, so I don't know if you can, let's see if, I don't know if you can, I don't think you can see it very well. But right down here is my language servers. So right now I have Pyrite and I got a Rough as a language server because I'm in Java, or I'm in Python. If I load up a TypeScript one, it'll have whatever the TypeScript language server. And you can, if you go into the settings, right, no, I don't want to do that. I just want to go into the settings. Probably have to switch to, let me see if I can switch to edit in JSON. And then if I wanted to do like TypeScript, I can, all right, so right here, it talks about the language server for TypeScript. And if I go down, if I find that guy down here, I can even set up some of my language server. I think this is it. Yeah, here is the TypeScript language server stuff, and so I can set whatever settings I want to add for that.
Do you have to install the TypeScript language server program, or is it just a plugin?
So TypeScript, Python, Rust, and I think there's one more are baked into Z, but like Java is not. It is a plugin that you have to add that support into. But TypeScript is already built in there. And the really cool thing is this is actually in your .config file in your main folder. You'll have a Z folder, and in there you'll have your settings. One of the cool things I did was I actually went in there, opened up that settings in Z. I was having some trouble with TypeScript, and so I used Copilot, and I said, I'm having trouble with TypeScript, fix my TypeScript integration. And it went through and made some changes to my settings. I saved them. Once you save your settings, they automatically take effect. You don't have to reload or turn off, shut it down and turn it on. And yeah. All right, I think I have blown past my time, but thank you.
That it? Oh, there we go. Hello? Is that working? Ah. Yeah, I made this mistake of having one of those last time. It has caffeine in it.
I'm not a public speaker.
Dang it, which screen is it on? Screen mirroring.
You might have to switch it to mirror. I don't know if I did that. I don't know if I have.
Not now. Daryle, do you have any pointers for screen mirroring?
So I ended up mirroring. So I went into my settings, so display settings.
Yep.
Oh, see, it's pointed up there.
Oh, dang it. Where's my mouse?
Your display is somewhere.
Instead of main display,
Not that way.
switch it to
You can't reach that screen. It's the I know.
here.
That. Not this
How
one.
many engineers is that?
Yeah, I don't know.
Maybe unplug it. Can you unplug it? Will it show up there?
Okay, there we go.
And then you might have to move it a little bit so that it will stay on that screen.
Just move it to here.
Yeah, just move it. Yeah, now try
What?
it. Maybe it'll stay.
That's not the right slot.
Don't plug in your SD card.
Oh no.
If that doesn't work, you can go here to this guy,
Yep.
and there should be a little
Because
mirror.
I was trying this before.
No, not this.
Not this one. Stage manager.
There should be a. Mine has a mirror. What is that guy right there?
This is the mirror
Oh.
or extend.
Why can't
But-
you move your mouse to the right, left, up, or down and get on that monitor?
Oh wait. No, that.
I mean, like physically.
No, I tried going left, right, up. Oh, you got up? It's up.
Okay, you have to go next.
You want mirror?
Mirror.
Yeah.
There we go.
There we go.
Only 3 to 4 of us. All right. All right. Let's go. My name's Joey. I'm here to talk to you about what actually happens when you activate your venv virtual environment. Who here uses Python? I assume just about everyone. Who here uses virtual environments? Good. That's the right way to do it. I'm going to focus on the Python module that's built in that venv and the POSIX compliant script, just because I don't want to deal with the whole family of scripts that do kind of the same thing. So let's full screen this. And I had fun making this little GIF. But let's go. So you all probably know why we use virtual environments, but I'll just cover it real quickly. It's isolated. It prevents the dependencies that we install from messing with the ones that are already on our system. This is really important when you work on 2 or 3 projects at once, and they might require different versions of the same dependencies, or maybe you overlap in name with another dependency that is out there. So virtual environments exist for a lot of different tool chains, but Python's what we're talking about today because it's a little weird, and that's what we're here for. So if you don't use virtual environments, all of your dependencies get installed globally, and that's how we get these conflicts that I've been talking about. And I'm sure at least once, sometime in the past, some of you were naive enough to run into that without a tech lead to tell you, no, don't do that. But today, we're going over the activation script for Python's virtual environment. This is just the high level, kind of starting each paragraph in the activation script. So we see it defines a function. It calls that function, It has a condition here that if you don't know what that stuff is, it's to deal with Windows, because Windows is silly. And then it exports the path, it unsets Python home, exports PS1, and calls this weird hash build. No idea what it was. And it was fun to learn about. So some of you may have wondered why you have to dot source the activation script. Does anyone know off the top of their head? Don't read the slides. Matt?
You want me to answer?
Quick answer's fine.
So if you just execute it, it will run in a subshell.
Yep, that's perfect. When you dot source the file as you're instructed to, it's as if you're running every command in that file in your own shell. And that's also why we have that interesting deactivate command that we get to run later. But some of the variables that are set and unset, I think this is all of them, but it sets virtual env and virtual env prompt, which are both to be used by other programs if they're interacting with your virtual environment for Python. It updates your path. I'm sure that most of you know, but your path is a list of directories that your shell searches through when looking for a command, like if you execute Python. It goes through and it finds where it appears in the first directory in that variable, and then it executes that one. If you have other Pythons, they don't matter. They're way too far down the list. They're not up in the pecking order. It unsets the Python home because that is where you can put the standard Python library, Python standard library in custom places. And your PS1 is your prompt. That's how you make it look pretty. Then it has the underscore variables, which are where it actually stores the old thing so that when you deactivate, you get back to your normal shell. So I've taken the activation script and I've just broken it out into a few code blocks to make it easier to digest. When you run the python-m venv command, it actually fills out things like your paths that are used in the file. So that's why we get to see my username there. And folder structure. So this part is for Windows or for Unix systems. It's just determining what the path should look like for the virtual env environment. Just doing silly things for Windows, doing normal things for everything else. Here, it uses the virtual env path to construct where the bin directory in your virtual environment is located and put that at the front of the path so that when you type Python into your shell, the first one that it finds is in your virtual environment bin directory. That's how your Python version gets switched when you activate the virtual environment. And then it has to export it so other programs can use it. Here is just unsetting the Python home if it's there and storing it away in a silly variable name. And I've found I don't really use the Python home variable, so this section was fun to look into. Here is the little bit of visual flair that you see when you activate the script, because usually what it does is it puts the name of your virtual environment on the front of your prompt, so you can see really obviously I'm in my virtual environment now. Or you can set this variable and tell it don't do that, don't mess with what I see. Or if the folder name is kind of silly and you don't want to see that. Then these are two of the coolest parts of my presentation. The hash command and how I'm going to demo it, because I saw this command in there and I had no idea what it was doing. What it's actually for is when you run commands in your shell, they get stored in a hash table for quicker lookup. And so #r clears that table. So if you have a saved Python somewhere out there, it's not just going to automatically go to that. This is saying, nope, you don't know where anything is. You're going to search again. So this is actually my shell. We can run stuff, and I'm just running a couple silly commands here because I want to show #-l, which shows some of the commands that I've run. Python eza is my ls. Get another one in there. Apparently my key bindings don't quite work. But now if I list things, I have a few things in my hash table. It knows exactly where those are, and it's not going to use your path to find them. You can delete those files, and it's just going to say command not found. Or you can put something else there, and it'll also be kind of silly. But if you run #-r, it clears that table. And you have none left. And it needs to do that at the end so that it researches your path for anything that's in the virtual environment. I was just really proud of getting my shell into a slide. And then the last part, which is also the top of the activation script file, is deactivate, which is where all the things are rolled back to the stored versions. And this function is just there to set your shell back the way it was before. Every variable we went through before, the old value is put back in its old place, and it's like the virtual environment never happened. And really, the script isn't very complicated, and you might think something like this is actually what you could write for your own projects. Like if you have issues with other projects that, oh, I need to install my dependencies here, I need to change my path, change these variables in this way for this to work. All of your setup for a project that you might do in a rake file, a make file, whatever, you could do it this way, but you probably won't put yourself through that. And that's just the end of my thing. I'm open to any questions. Daryle.
Have you ever changed that file?
I have not, but I did poke around with it quite a bit, and I could put silly things in there if I wanted. Jack.
What prompted this exploration?
I always thought that file and virtual environments were kind of a mystery. Like, I, for years, just used them, and I was like, I don't even know what this is. I do all these other projects where I have to install stuff here, and then later on, maybe I need to change those versions, need to roll it back. Maybe if I'm developing on something locally, I would want to take the bin out folder and put that in my path. So if I'm developing, say, my editor's Helix, I don't contribute to it, but it's another Rust one. It's kind of cool. But if I were to build the a local version of it on the master branch, I don't want to mess with my one that's installed. I would want to have a way to change my path and change it back so that it knows, hey, I'm going to go look at the new one. I'm going to find that one first. And so that's the reason to look into it. I actually use a program that's similar in the effect to a virtual environment called venv, which I use for this project to install all the other tools that I used, such as ASCII Cinema for making the GIF that was there. ASCII Cinema was for recording it. AGG was for making the GIF. MARP CLI is the tool that I use to make this presentation. It's all Markdown. It's all one document aside from the other files. and TTYD is how I served my shell to be available here, which was a lot of fun. And then venv. Yeah. Hello.
So, my name's Nathan, by the way.
Nice
Nice to meet you, Joey.
to meet you.
My name is, or what I've been working on recently, is I've been working with virtual environments, right? And I work with very experimental packages. And one thing that happens a lot with virtual environments is someone will write a requirements file, but they won't freeze the version, right? You know how in requirements you have to set it to equals, you have to set the version. So I recently discovered there's this really cool tool. It's called pip compile. And it's built into the UV package manager. If you type in UV pip compile, it will look at all your unfrozen dependencies and freeze them in the virtual environment. So my broader question is, how do you deal with dependency conflicts in the same environment? Like, what if you have two packages that conflict with each other? Have you ever encountered something like that?
No, I haven't, but you have two. You have a limited number. You're just, here's one version of it, here's another.
Yeah.
Is that correct?
Yeah, so I've dealt with breaking changes where if it downloads the latest of a certain package, it will break another package. And I guess freezing it is a different problem, but I guess my question is, like, I don't know how to deal with dependency conflicts in an environment. I was just wondering if you knew.
Yeah, I would clean install, but you can have multiple virtual environments. That's why the last argument to Python-m venv is the directory. So you could make one for your stable version and another virtual environment for the fresh version.
Okay, that makes sense. And there's no way to get those two environments to talk to each other, though?
I don't know why you would want it. I guess I don't really understand the use case of having those two environments overlap. But yeah, that shows my limits. Anyone else? Otherwise, we're going to have to pass it off to Joseph over here and see how it goes.
Test, test. Awesome. Okay, let me see if I can do this in one shot. Nope, okay. Do-do-do-do-do. Oh, it showed up down there. Okay, so today I'm going to talk about asserting yourself when it comes to writing Python, or bending it to your will. So, who here has written code? Wait a minute, that's not done. That you're sure would never fail. There we go, that's more like it. That passed all the tests that you wrote until some pesky user came along. That was validated, that you're gonna make it validated in the next PR. Don't worry, we're gonna clean it up in the next PR. And then that PR never came. And sometimes it just breaks because the impossible becomes possible. The speed of light, we really thought it was that one number, it changed. Oh no, all that code that relied on it, it's now broken. This happens a lot, unfortunately. This is why we have a whole maintenance budget, right? We need to maintain these things to handle what some like to call the entropy of the universe, or clients who don't know what they want. So that's the main why, but there's a technical definition for this, unenforced invariance. Yeah, we all know what that means. So the heck is an invariant? It is a logical assertion that is always held to be true during a certain phase of execution of a computer program. So the heck is an invariant? Basically, here's a small example. I love examples. So here's a list of grades. They're just integers, 90, 80, 170. The invariant is the statement below it. Grades are numbers between 0 and 100. This is a logical statement, implicit or explicit, that all your downstream code, your upstream code, it has this assumption. So when you write your graphing library or your statistics library or all your 15 different libraries or your downstream code, it assumes this is true. And everything's great, and everything's perfect, and nothing ever, what? Who did that? Who validated your invariant? Well, anything could happen, right? Maybe we didn't validate an input, maybe someone's getting extra credit now, right? Well, now my graphing library has a line above 100%. That looks weird. My statistics, my calculations, everything's crazy. How did this happen? Well, we had an invariant, and it's still right there. Look, grades are numbers between 0 and 100. It doesn't do anything, though. It just looks pretty, and now it's lying to us. So a lot of us are just like, great, let's just use some libraries. Let's use some types. I will not get on my soapbox about how sad types are in Python. Or let's use Pydantic. Let's use some libraries. Let's validate our inputs, validate our outputs, validate the boundaries of our application. That's going to work for a lot of cases, but that is the high-level solution to this. I want to invert it and talk about the mental model of what those are doing. Those are asserting your invariance. So let's not make a comment that says something. Let's make the code live as if that is true. Now, I use the word assert because I love the word assert. I also use the word assert because Python has a built-in keyword. It's so beautiful. Look, it has a different color than the other words. My mind loves that. So you just provide it an expression that evaluates to a Boolean, and if this is true, nothing happens. Everything's great. But if it's ever false, it automatically raises an assertion error, and if that message is a little sad and ugly for you, you can provide a custom assertion error message as the second argument. We did it. We solved the problem. And here is this invariant being held to a higher standard, being proven true. Now, instead of errors downstream, or what can be even worse, unexpected behavior, we have an error and someone will go fix that. Some user will report it and be like, hey, look, you changed the requirements? Okay, we'll update the program now. But some of you Python experts, you're pushing up your glasses and being like, well, actually, this isn't perfect because in Python, asserts are not forever. You can run Python with this -o flag. It's called the optimization flag, and it basically optimizes Python. It does this by getting rid of doc strings, asserts, and a bunch of other stuff, making our beautiful code that was making sure our grades were always good and forcing our invariant effectively look like this. Oh no, they got through. Now the easy solution is just don't run that flag. That's okay. We don't write Python to be fast anyway. But can you trust your environments not to run this flag? What if AWS wants people to go fast, or your Jupyter notebook, or wherever your Python is getting ran that you don't control? This could sneak in there, and if you really care about this quality, then you don't want to rely on this. So we won't use the assert keyword. We'll assert it in other ways. It doesn't look as nice, though. We have a not in there. We have to use parentheses. There's indentation. It works, but that's kind of sad. If you're doing actual input validation, do highly recommend Pydantic. It's kind of built for this. Look, it's so easy. You just use types, annotations, and you can just define it. Very declarative. Big fan of that. And if you really want the assert ergonomics, you can just build your own assert. Call it ensure or something. Do the same logic, and it feels like you're using assert. Sure, you have those extra parentheses, and it's not syntax highlighted the way you want, but that's fine. Not to me. It's not fine. I want my asserts, and I want to be able to safely rely on this, no matter what optimization the code base is running under. So this is the part where don't do what I say. Don't do this. This is bad ideas, but they're fun, which is one of the things I love about Python. So I'm going to introduce you to import lib and AST, with the goal of turning the above function, which I've simplified very much because we do not want to look at a jungle of an AST tree, that just asserts that the difference we get from these two numbers is never negative, relatively simple. But we know that top one is problematic, because that assert, it's going to disappear. We don't want that to happen. So we want it to look like this. But we don't want to write this down here. That's ugly, but we still want this. So the way we're going to get that is by changing the AST of the code as you import it. Now, very brief primer. AST stands for Abstract Syntax Tree. This is a quick, just online tool I found that visualizes it, because the code we write is not what the Python interpreter sees. It's not what any language sees. It gets turned into these nodes and these different values. So it's a little hard to see, but you can see that assert is here. It has two attributes, a test and a message. The test is a comparison between a variable named A using the greater than operator against a variable named B. It's all the stuff we were doing, but this is getting to the nitty-gritty of this. And this looks scary, but this here is just the formatted string. There's, again, lots of magic there, but all that really matters is that we have this, which is the AST for that assert statement, but we want this, which looks like a lot changed, but these two sections, the comparison and the joined string, are identical. All we changed is there's an if conditional that says not the logic, and we're manually raising the call. So that doesn't sound like a lot of changes, and it's not. So what I actually did was I threw this together. So if I were to just run this now, it works, beautiful. But if some sneaky person come in here optimizing my code, I never asked for that, oh no, it's gone. The error is getting through, and that's because we're just using the assert keyword. This is the same function I showed before. But let's bring in this magic assert library, and I'll go through it step by step, and we'll see with the O flag, boom, the assert's back. How do we do that? Well, this is where we introduce our other villain in crime, import lib. So if you've ever used the import statement, which you kind of have to, technically you are internally calling import lib, which is the way of programmatically importing Python and doing all the hard work that it does. We can override it. We can change its behavior. So like all Python files, it starts at the bottom where we insert a custom class into metapath. This is actually very similar to what Joey was talking about path of this is a list of things that it will look and call of, I'm going to call this first one. Did you find the thing after the import statement? Nope. I'm going to look into the next one. But we insert r's at the very beginning, so we always go through our magic little finder. And our magic little finder is, again, gotta love types. When they do work, they're beautiful. We are implementing an abstract, find spec. I'm not gonna go into that. A spec is basically, think of it as metadata for a module, location, information, and how to load it. How to load it is important because we're going to say, you're not gonna load it normally, you're gonna load it with the magic loader. And what's the magic loader does? Well, it does all the boring stuff. It gets the file, it reads it as a string. That's not exciting. But after that, it sends it to an AST transformer. This is where AST comes in. And what this is think of this as something that goes through every node in the AST tree. I just said ATM machine. But it goes through it and it checks, hey, should I change that? Hey, should I change that? And then it changes the ones it should. So we override what happens when it looks at an assert node. So when it gets an assert node, it's first going to make an if statement, unary operand, using a not, and then whatever the original expression was. It's then going to build a raise statement, which is to say call to an assertion error using whatever the original message was, or a placeholder one if you want. It's going to put the raise statement inside the if. You can't have an empty if. It's going to lie a little bit and say they're all on that same line of code. Don't worry about it. It's going to fix the missing locations, so like all your line numbers line up. And then it's going to say, yeah, that's a cool assert there. No, you don't have that assert. Instead, this if statement is what you have in its place. And that's what allows it to, like actually when you run it, you can see it's actually highlighting the original line of code that this actually threw on and not like 5 lines off. Now there is one thing sad about this, and that is, I will show what it looks like without. And this is why it's not production ready. The only reason it's not production ready. It doesn't highlight the 3 characters of the expression that was originally thrown. And that is the reason, the only reason, no other reasons, you should not use beautiful magic like this in production. Now you can use it to do some other curse stuff, but I will leave that to your imagination. Maybe you want to add a comment with a unicorn emoji that automatically installs a crypto miner. Don't do that. Do something more friendly, right? Maybe you want to hashtag console log. You can do all kinds of crazy stuff. Good luck getting anyone to approve it in production, though. And that's one of the fun things I love about Python. It just lets you do what you want. So, any questions? Yes, Joey.
What was the most surprising thing you learned when going through this?
I thought I'd have to use regex, and I was like, oh wait, I don't. I can just target it directly. Because like the core idea is that I like my asserts to be this readable and ergonomic. And I know from a Python perspective, they strip them out because they target them for testing and there are historical reasons, but let's make it your own, right? It doesn't have to be the way it is. It can be the way you want it to be. So the surprising aspect was how I didn't have to use regex and how the AST and the modules, like, if you look in the code, I didn't have to necessarily, like, nothing here is underscored, right? So I'm not using any private secret stuff that I shouldn't be that's gonna change on a minor patch version. This is just public. This is the API for the import lib. So this is just out there for anyone to use as they see fit. Any more questions? Okay. That's fun thing is it's going through like 6 options back there, so it's a miracle it works at all.
All right. Do you guys hear me at all? Sweet. Do you see a display? No, you do not. Am I on the wrong one?
No, you're on the right one.
Let's go direct HDMI. That's not even picking it up as a.
Yeah, it should be fine.
Okay.
Oh, it can hit
Oh,
something.
they got
There we
something.
go.
Here. Changes. Sweet. I did a thing. All right. So, my name's Cory Gideon. I'm a CEI engineering manager at Wellabe, so customer engagement and innovation. And one day I just got this wild harebrained idea of I want to learn about some some data structures and algorithms. I want to learn Python because I'm a C# dev, so I want to learn Python. And then I want to learn more about memory stores. So, you know, what's the biggest memory store out there? Redis. Why don't we build it ourselves? This was the start of nothing but a headache. Because, you know, I've been doing this for almost 15 years now, so I'm somewhat of a developer. Been doing a lot of C#. But Python is not one of my skill sets. So let's throw as much new stuff out at me at the same time. So what are some reasons you might want to build your own? You want customizability. You want to learn. Or you think you can do it better. Can you build it better? No. But I've got all this experience. I'm really good at doing this. No. You have Google, Microsoft Azure, entire companies contributing to Redis. That's lesson 1. Use what's already out there. Don't reinvent the wheel. So let's go ahead and cross that off. And let's go ahead and cross that one off too, because I haven't found a reason why you'd want that much customizability. So just keep that going. Just use what you have. So you want to learn. Great. Awesome reason to do anything. Good. Do it. Learn. Because it's a complex system, and there's a lot of moving parts to it. And it's one hell of a dragon that you can fight. You can beat it. It's just you're going to pay for it in headaches, time, and learning. So enter Radish. Came about because my son heard me talking to a colleague saying I'm rebuilding Redis, and he thought I said radish. So Radish. It's just it's a Redis-like memory store, very, very much in early development. So it's out here on my GitHub with full walking through commands, explaining how to run it. That's really small up there, sorry. So it does support some things like custom commands. Haven't tested that part yet, so that is kind of scary to even bring up. But we can just look at some code. So the main part that you're going to be interacting with is the server.py. So server, pretty much standard server, starts up a TCP server on a given port. Right now it's hard-coded because this is the Redis default port. So it just starts up the server, listens, gets that connection or those commands coming in, and fires them back into this command handler. This command handler, again, I'm working on optimization of it, but these ones work. So you can ping it, echo, set, get, delete, expire. So that was a fun experiment. How do you set an expiration on dictionaries? That's something I had to figure out. And the challenge I put out to myself on this project was only use Python standard library packages. Do not use external packages. When I was trying to research expiring dictionaries, there is a package, expiring dict, out there that you can download. But again, I wanted to do it myself. So this is thread safe. It does handle multiple connections. It has eventing in it, so when you have a cache or a store that is being manipulated, it can fire off events to listeners. I'm still developing and testing on that. But there's a lot here, and I'm gonna go ahead and share that. Like the event handler and the cache handler. Caching, I have it set up. It is 100% vibe coded. I don't know what it does. I'm trying to take what the LLM gave me in its code. I want to tear it apart, rebuild it, so I actually understand what the heck it's doing. Yeah. Maybe I've been out of development too long, but yeah, I vibe coded that. Now this commands handler was actually really fun to try and figure out how do you want to do different handlers, and how can you make it, the separation of responsibilities, pull some of this stuff out. So the biggest thing is we are taking the string that we're getting in from our users, and we're parsing that into different command parts and checking what that is and handling it. So ping, just return pong. Echo, return your string. But I can just go ahead and show the demo. So Radish. So it's listening, localhost 6379. And, oops, sorry. Yeah. So if we go telnet, localhost 6379. So set foo bar. Get foo, turns bar. Set r push. So I want to push something to the right of that. Set foo and bin. Get foo bin. That didn't seem to work. So live demo doesn't work always. Say we want to inspect foo. 3 arguments. Again, live demo. Echo. Hello. Hello. Ping. Pong. I want to expire foo in 5. So get foo. So foo's bin. Wait a little bit. No. So that's how we, and it's using the expiring dictionaries. Again, this is not anywhere near close to being what Redis can do. This has had a decent amount of development time. It has been a very eye-opening experience in learning how to work with Python dictionaries, some of those more complex data structures. As you can see in the repo, I do have this to-do list. All the things that have yet to be completed. So it's a very simple, or very quick overview of it. So yeah, some future state development I'm going to be doing is really fixing that cache system and the eventing. Also, I need to be adding in some logging, and I do have persistence set up on here, but I need to really have that set up on an automatic timer, so if your machine crashes, it persists it to a JSON file where you can then load it back up. As a quick overview, if there's any questions, I'm happy to do my best to explain them or answer them. Yeah.
What's been the most surprising thing that you've learned while working on it?
The most surprising thing I've learned is probably goes back to my comp sci degree. When I was studying, my professor said, if you're asking the question about multi-threading, you're asking the wrong question. So learning how to lock a store on a thread, that's been really interesting, so you don't have conflicting writes or conflicting data coming in. So learning how to safely do that has been really fun. All right. Well, thank you.